The step number 2 is going to be determine the forces on the gears. Just remember that in this example, we do have only 2 gears. Other example may have pulleys and belts or sprocket and chains. So in this example, we do have the gear at A, which is a spur gear, and we have another gear at C, which is going to be a spur gear as well. We know the diameters of these gears, and we know the amount of the power input, also the RPM value. So the process of finding the forces will start with finding the torque on this shaft. The torque can be calculated by dividing the power by the angular velocity. Thus, we are going to get the answer is going to be equal to 2,388.5 Newton meter. If I'm going to illustrate that on the shaft diagram, we will see that the torque is going to be starting from the gear A, where the work or the power has been fed to the shaft, and leaving at the gear C. After that point, the torque is going to be 0. We need to have a side look on the gears. So we said that and the gear A is going to receiving the power from the gear P. So the gear A is going to be the driven gear, and the gear P is going to be the drive gear. On the gear C is going to be the drive gear, and the gear Q is going to be the driven gear. This will help me to find the direction of the forces we are going to have on the gear A and the gear C. So what you can see in the gear A, that the force WTA is going to be rotating the gear A, thus is going to be pointing downwards. On the side of the gear C, you'll see that the tangential force is going to try to resist the gear C. So once again, it's going to be pointing downwards. In both cases, the radial force is going to be pointing toward the centers of the gear A and the gear C. The equation we're going to use to calculate the tangential force is going to be torque divided by the diameter divided by 2, which is obviously going to be the torque divided by the radius. The finding of the radial force is going to be tangential force multiplied by the pressure angle tangent. You can calculate the forces on the gears by using the following equation. So I will find that the tangential force on the gear A is going to be equal to 9,403.7 Newton pointing downwards. For the gear A, radial force is going to be equal to 3,422.7 to the right. The tangential force we have for the gear C is going to be equal to 18,807.4 Newton downwards. And finally, the radial force we have on the gear C is going to be equal to 6,845.3 Newton to the left.